Welcome to another video episode on my Arduino Mega2560, connected to a breadboard with some electronics and one piece of fischertechnik, which is the switch. The original intention, and still on the background, is an attempt to get something moving through this inductor. However, it has evolved into something else. Since I've been programming it using Octave with Arduino plugin, or Arduino package actually, for data acquisition, with pulse modulation. Pulse modulation because most ports are equipped or are intended to do pulse modulation. You can also read voltages, so I combine both. The objective is to use pulse modulation to send a signal over this circuit with a transistor, which is here, two LEDs, where this LED signals voltage from this circuit with the inductor, and this one just the voltage over the transistor. The switch just blocks or passes signal. Then two LEDs here, the green one to show if in the algorithm both the increasing pulse modulation and decreasing pulse modulation are 1, and the red one is for signaling if one loop has completed. The probes are attached to let me do a couple of things, to this oscilloscope. Pulse modulation after switch, and these are voltages, or intended to show them. Anyway, that's the intention. So with this introduction, let's go to the software and see how things go, because the focus right now is on getting all values in a graph, or in a respective graph. And what I have done is that the arrays, since Octave works with arrays, vectors, matrices in an expanding vector, each of those values in its own vector, and that has shown some remarkable outcome. So I'm trying to get things in a nice graph, and last time that didn't entirely work out. So this is the algorithm. I first load the Arduino package, then I assign a variable to it, and I initialize all vectors for their respective input, data acquisition. Some timing, which actually is the number of cycles that I go through the whole algorithm, or most of it anyway. Then this is increasing pulse modulation. Here is decreasing pulse modulation, and this LED shows that and by the way, that's in one of the vectors as well. This one is sometimes also 0 and mostly no, sometimes also 1, just like this one, and mostly 0. Why that is, not quite sure. Then reading everything, and I should select the proper column. Here I read D6 analog value, which is an actual voltage, and the strange thing, as you will see, and if you watch the previous episode, then you will have noticed that although these instructions do actually exactly the same, so both values in V4 and V41 should be the same, but they are not. Same goes for A1. Should be the same, they are not. Why? I don't know. Same for this one. Should be the same, they are not. And in the end, after 8 runs, I put things in a plot. I ended last time with an error which I managed to fix afterwards. So let's run. And in order to have a good run, I have to hold the switch. And let's see, and in these two you can see the increase and the decrease of the pulse modulation. So let's have a go at it. I have to be careful with the wires, so holding the switch like this should show all LEDs properly. And let's go, pressing F5 to run. And there you go. Oh, then I noticed that they are very small, so I interrupt the program because I need to set the voltage from 10 to 5 volts. Then you see something properly. Now you can see some nice, real nice values. So repeat, go. And now you can really see what is going on. And decreasing pulse width, which is the second part. Alright, red LED flash, so that is good, and that happens 8 times, and after that we should see some nice graphs, and hopefully a green flash as well, which means that at least one of the things is positive in decrease. But will it show something? No green LED yet. And yes, this is a boring part. So let me interrupt and then show outcome. And I of course meant to interrupt the recording. So now we go, and the green LED only shows when this one for V1 and then the second element is okay. Well, this one is clearly not okay, or not okay meaning 0 instead of 1. you see the increasing number of elements in the program, and yes, I actually can skip this or change the algorithm that it is only shown once, because that is more than enough. And you already see the varying values from A0. This should be voltage as well, but it's analog pin actually, analog reading. And the further you get, the more varying voltages you read. And that is most peculiar. Look here, half, and this is a very big difference. Although they are both less than 0, less than 1, even this is remarkable. So I have some graphs, and the strange thing is, why does it only do one graph? Oh, now it does two. Alright. Analog and voltage. So yes, I did that in the last part of the algorithm. The labels. Analog. So these should be the same. And well, except for a peak at, well, here at 3 and here at 4, they are completely different. This is decreasing while this is increasing. Here are two peaks, but except for both increasing with a decrease, it doesn't look like the same at all. Well, except that this peak is earlier than this one, and this is more or less the same. Which is A2, and A2 is coming from, which is, yeah, this wire coming from the circuit. So the circuit is consistent, the rest unfortunately isn't. So what to do? Well, first a piece of text outside. Can be very well done here. And then this one that's good. Save some space, but more important, yeah, okay, I can add here analog, analog, and analog. But the main question is, of course, why are they showing the wrong value or different values? Because of course I do not know which value is actually right. Let me get the schematics again. So, wiring. This is all input for data acquisition. Here is no label yet, so let me add that this is pulse modulation out, or output, better. Then this is of course for this project not applicable. This is 52, and then it's better to look here. 52 is a gray wire that goes to this red LED, signaling the start of the loop, or end of one loop. So actually also pulse modulation. However, how is this set? And this is D22, D25, just 1 and 0. So no pulse modulation, just 1 and 0 digitally. So let's say red LED end of cycle, and this is a digital thing. Then of course this one is then automatically green LED. V1 and second element is 1, which is, needless to say, almost never the case, but that's another thing. Alright, everything properly. I can change this a bit. That is better. And all this can now go. Not needed here. So the big question is, why are now I'm curious. Okay, yeah, this is 4 and 41. That's another thing. Slash V 41. 6 and 61. Seven and 71. So that makes it immediately clear that they are exactly the same values. There's no difference. So why are they showing different in the output? That can only mean that the respective functions are have some difference, but which one? So back to the manual again. Alright, I have read the documentation, and they give somewhat of a description per function, which I have now written as text. Actually, this is more or less, well, actually the literal text that they give, except for this one which I added, because they say it is voltage and then the description is analog value of the pin. So I make it analog voltage value of the pin. since it is returning the voltage. Then read voltage, you assume it is the voltage because that's the name of the function, and they say scaled pin value as a voltage, and that's literally what they say. So you would assume that it's the same thing, but actually I think if I look here, how are they the same? I do not see how these values are the same as these values. Unless they are very small, that 12 is equal to 0, because it is off limit. Then again, the difference between 161 and 74, I don't know, it's almost half, and this certainly ain't half. Then 89 and 81 are very close together, and these two are not really close together. So that's doubtful. Anyway, let's do another run and see what result it is. So first is save, go here, hold the switch, press enter, and there we go. Let's see one run, and the rest I will do off screen. Which also make me very curious about, that's one cycle. And another thing is, you might notice that top oscilloscope line is dropping down. No clue why. Something in hardware most likely, but anyway, that's something else. And the rest I will do off screen. Right. It has been completed, and I didn't see the green LED, so this value will always in this run be not okay. And here you already can see some differences. Well, in text anyway. But then again, if you look at this value difference of 16 and here, that is well, too much of a difference. And this actually is not so much of a difference. Then again, the figures were almost the same with V7 and V71. So let's see how that works out with the rest. Yeah, here a big difference. Here it's in the same range, while here it is a massive difference. While it's the same pin output actually, they can't be different. Here the same thing. Hard to believe, and yet it is. Oh, here a zero value. 66 against 61. How to explain? Going further. now seen. Let's go to the figures. Yeah, how to explain it. The top is at 5. Here the top is also at 5. And it has the same kind of shape, though this goes much deeper. Of course, the vertical values are very different. And here this has a flat top and this has a very sharp top. And this is pretty much the same, if not totally the same. So you can see that this is different value, and yet the figure is the same, so that is no problem. But this, I can't explain this, or these actually. Exactly the same values and yet totally different. Alright. Going to wrap the video and searching later for a possible explanation, because of course there is one. Alright, like I said, that's it for now. With some changes in the algorithm, but not too much, most for clarification. Graphs, not much to explain yet, so probably I will ask the developer. Thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion, much appreciated. You can also follow me via Instagram and Twitter. Please show your support for this video and for my blog by making a donation via either PayPal or Wired. More information on my website. And you can also choose to become a patron and have your name mentioned as a supporter if you like to do that. Very much appreciated as well. And your name will be mentioned on my website, and depending on the pledge you make, also with my videos. All information you can find under this video, including the URL of my website. And yeah, well, this is going to be continued obviously. So have a nice day and bye bye.